So we're going to talk about objects, and you'll see that those are, in a way, tightly coupled with what we talked about right now about functions. They're a crucial part of every modern object-oriented programming language, and the concept is pretty clear if you've used any other modern language. So just like the concept of functions is clear to anyone who's built any kind of software, usually the concept of objects and object-oriented is also part of any modularity architecture of every software. So objects would represent models that have certain properties and models that have certain functionalities, and usually they would be modeled after real-world objects. Real-world objects. Yeah, we have here a few examples like bank account, dog, car. Usually these things are used to these things are used to as an example of objects in the real world. So if we take, for example, real world object like a bank account, we have things like bank account status, bank account balance, bank account type. These are properties of the bank account object. And if you guys worked for, I don't know, a financial company or something like that, then this could be very valuable for you. So in software, we try to implement objects that try to imitate and implement real-world scenarios, because in our vision as humans, we usually classify the world and we have certain understanding of how things work, and we can see a table that has a color and a height and material, a car that has a brand and whatever. So these things usually go well with our understanding and our modular concept of the world. So objects in software try to imitate this understanding and to break the software into modular pieces that give us some structure and some consistency. So yeah, we see some examples of objects and what they can represent. So in the real world, this would be things like people, cars, dogs, animals, and so on. And in the computer world, they would be represented by numbers, characters, arrays, variables, and so on and so forth. But somehow these things need to blend together. When we talk about objects, we come to the definition of what we call in computers usually a class. I'm not sure if in all programming languages that are somewhat object-oriented, the object will be called a class, but in many of them it will be called class. So this is a definition by Google. Object acts as a template from which an instance of an object is created at runtime. So this is our template to create object, and the class is just our definition of what this object would contain. Types define the properties of the object, and the methods, which are functions, used to control the object's behavior. So this thing, when you put them all together into what we call encapsulated object, that's part of the principles of object-oriented design. The one is called encapsulation, which takes stuff and puts them inside your class template. And some things are accessible to the outside world, and some things are hidden inside your class. So here is an example of an object called account. We can see that it has a type name, that the name is account. It has certain attributes, which we refer to as properties and fields. Some of them are accessible to the outside world, and some of them are not accessible to the outside world. They are just made for the internal usage of the object itself, and it has operations or functions, or sometimes referred to as methods. So this thing is a whole box that would define any account which is modeled after this class, after this object type. So the object is the concrete instance of the type. So first we define what our object contains, what properties and what methods, and then we create actual objects which are instantiations of this class. Yes, objects would have a state. That means that they have values to these properties. So if we have an account, it has an owner, which is a person, that's the property. But when we instantiate and actually create an account in the system, then owner will be, the owner property will be populated. And so this object now has what we call a state, which means it saves some certain data about itself and about its characteristics and properties. Okay, so here is, again, the account object as an example, and here are 3 different objects which are modeled after this account. So these properties can be defined, can be assigned to different values. So each of those has a different state, meaning different values of different properties, and each one of those objects will be supporting these methods. You can call these methods from each of these objects. That means they support these methods, and you can run methods through the object. JavaScript allows creation of objects with different methods in different ways. There are some built-in predefined objects in JavaScript, like the math, which gives you all kinds of mathematical functions, document and window, which gives you information about your document, your HTML document, and your browser window, and so on and so forth. You can also, of course, create your own objects, but it gives you also the freedom to enhance and improve the existing objects. You can go to the built-in objects, and you can build further functionality into them using what we call prototype in JavaScript. So let's see what we got. So we have a few calls here, basic calls. Oh, no, not you. So if we have a few basic calls here to some object properties and functions. We have a function called padLeft that takes a number and the number of digits, and it will take a string, and here what we see is that we're calling a string function that we'll see a bit later today when we talk about strings. It calls the string built-in function method called substring that will take this long string of zeros and will narrow it down to a shorter string and then concatenate the number that we give it. So what it does, it takes a number, integer number, calculates how many binary digits it has, and then would print out it was actually print out not just the number but all the numbers between 0 and this number in binary format, and this pad will make sure that all the numbers here are in the same length with padded zeros. So what we got here is basically a few calls to object methods and a few calls to object properties, but these are just a few built-in ones, and we'll see a bit more about them. So there's not a lot of object stuff here, but I think this demo is not sufficient, so we'll continue to better demos. Forget about this demo. It's a good demo, but forget about it. Okay, when we talk about objects, another thing to remember is the difference between reference type and value types, or in JavaScript they're sometimes referred to as primitive types. But this again has different implementations and different behaviors in different languages, but the main concept is the same. JavaScript, as we know, is typeless, but it's not really typeless, but actually variables do have types. It does have these 6 basic built-in types: number, string, boolean, null, undefined, and object. So object, except object, anything that is an object, values are copied by value. That means that if I take a variable and I assign its value to another variable, or if I call a function and I send this variable to this function, their value will be copied into the function. So if I make any changes inside the function to the variable that I sent, they will not affect the actual variable. We'll have a copied value, and they will both live side by side. when we are doing copy by reference, what we're actually copying is a memory allocation address, and we're transferring this address. In that way, when we have a variable which is an object, and we go into this object and make changes, we're actually pointing to the same location in memory and making changes to the object itself. So that's why this thing is called reference type, when we actually have an object where we can reference it from different places, from different areas, areas of our program, and affect it. And the value which is being copied between those two areas is the reference to the object. That means that we're actually making changes to the object itself. So object is the only reference type in JavaScript. All the rest are copied by value. They are primitive types. Okay, what we see here is, I just talked about this with Danshu just before the break, or during the break, that arrays actually give the same type as object. So arrays are actually object in the language. So if we compare the type of array to type of object, this will get true. So this actually evaluates true. And if we take an object and compare it to date, which is also an object in the language, this will also evaluate to true. So we have a few built-in reference types with different names, but actually they are built on top of the object, of the basic JavaScript object, and those are all reference types. So they derive from object. We'll see a little bit more about deriving and changing objects, even the built-in ones. Let's see if we have a better demo in this case. Yeah, that's a good demo. So that's exactly what we saw. Oh, no, stop. I have to stop with this. So that's exactly what we saw, that these three comparisons actually return true, because these all are object types. But just like I showed before that, we can have a variable, let's say x, which would be an array. So x now is an array, and if we check type of x, we'll get object. But we can use the array.isArray function, and we check x, but this will give us true. So we can check the actual type of our object. For example, if you want to check if it's just a random arbitrary object, or you can check if it's actually an array object. So this will return true. But if you check the type of, you cannot rely on this to tell you if this is actually an array or not. Yeah, so primitive types, like I mentioned, all the basic types of the language, like number and string, those are passed by value. And as you pass them as an argument to a function, you will not affect them the external variable that you just sent. There's new allocated memory in the stack. We talked a little bit about the stack when we talked about functions. And the value is copied into the stack of the function. Once the function finishes running, the stack is being popped out, the last entry of the stack, and our original variable is not affected. There is also a way to, we can see here two ways to create objects of primitive types. So first one, if we say number here, the variable number is equal to 5, we are creating a primitive value of type number with the value 5. But what we see here is this is a wrapper object of type number that holds the value 5. These two are slightly different because this one is an object and this one is a number. So basically this is an object which represents a number with the value 5, but this is just a piece of memory containing the number 5. They are slightly different And I think we'll see a little more on those and how they work, because I think there's another slide talking about this again. Okay, so an object, that's one of the ways that we can take our primitive types and construct an object. We'll see, again, we'll see it in more depth in a minute, but we have here two strings which are assigned to values, and here we're creating an object called person, and actually a variable object. The variable is called person, and it has these properties: first name assigned this value, last name assigned this value. The point here is that these are primitive types, and even though I'm taking this and I'm now changing the value here of last name down here, this has been assigned into the object here, but I'm taking this last name and changing it. What I'm going to change is this copy and not this copy, because there are two different copies in memory, and that's the idea of the primitive types. About this structure of how the object is created, we'll see it in a minute, but just to get an understanding that what we'll get here will not affect. These are two different copies of the data. So they're copied by value, and they don't affect each other. So we got here these two representations of number. This one is the basic primitive type of number, and this one is an object. This is what we call in C# and maybe other languages boxing and unboxing. We can take a primitive type and we can box it inside an object, which would be making it into a reference type wrapper, and also sometimes giving it access to some properties which are defined in the class that we are wrapping it with. But basically these two are representing numbers, and we could unbox it back into the primitive type when we need. So we are checking here whether they are equal with double comparison. Then we're checking if they're equal with triple comparison. Then we're checking the type of these two. We can see what would be the type. And then we can see if the type ofs are actually the same, even though these two are actually containing the number 5, but with different types of representations. And here we'll have two strings. We're creating here another, let's say, person variable, but actually what you can see, we'll talk about this notation, this JSON notation in a minute, but the idea here is that we're just copying the value into another variable, which is an internal variable of this class. And when we're changing this variable, which was defined here, we're actually not affecting the copy of the data that we have inside our class. So let's take a look at the results. So number and number objects actually contain the same value 5. So if we compare we use this very limited comparison with double compare, we get true. But if we check if they are really the same with triple comparisons, they will not evaluate to the same thing. The first one evaluates the number, and the second one evaluates to object, actually. Even though if we compare them like this, they will both get evaluated to the number 5, and they will both be they'll be treated as equal. And you can see here that if we compare the two types, we get false. Then we get here the two names that were defined outside of the class. Then we're changing the variable that was, again, outside of the class, this one, changing it here. Even though it's been assigned here, it will not affect. Those two are now two different variables, even though one of them is in the class, one of them is out of the class. The name was copied, and since this is a primitive type, they are copied by value, and when we make a change, we're actually not affecting one another. So even after we make the change, we'll still get the same result after we print it out. Reference types are different. Like I mentioned, when you have a reference type, like an object, what you get is things are actually copied by reference. That means that one copy affects the other copy of the same value. So, for example, here we have an array called marks, and inside this array we have a collection of objects. Again, this is a JSON notation that we'll look at in a minute, and each of those has a property called subject with a string and a score, which is a number. This is a collection of 4 such objects inside the array. And here we have another student with another object with a name, and the marks, which is actually an array like one defined here. So here we go to the marks array. You see that we have 2 variables here. One is here called marks, assigned to this thing. That's an object. And here we have another object containing this variable here. So it's just like we did with the string, just that instead of string, we're copying an object into the other object. See it? So we go to the marks, which is this object. We go to place number 2 in the array, which is this one. And we change the score, which is this value. And what will happen is that we're actually affecting also the ones which are assigned here, because they are copied by reference, and the references are actually referencing the same point in memory. And when we make changes here, we're actually making changes in here as well, because objects are allocated just once in memory and just being sent references. So I hope it works. Otherwise, it's a problem. Okay, so here again, there's a small function here to print a student. I'm not going to get into it, but it just prints the marks and all that. So here again is our array. So these are the marks. We have subject to each one and score to each one. We have a student, and this array is of this object, actually a reference type, is being copied here into this object as a property. So when we print the student, we're going through the properties and printing them. Now what I'm making change is not here, but I'm making change here. I'm going to this variable and making a change in it. And this, once I print the student again, we should see slice and dice updated from 6 to 550. So if I'm right, okay, so here's the first instance printed out as 6, and the second one was 550. So it, sorry? Meaning this one. You could not, because these are primitive types and they do not affect each other. That's the difference between the examples. So when I change a string, even though this string has been copied into this object, when I change this string, it will not affect the string which has made a copy into the object. However, if I have an object and I copy it into another object, and then I make a change in the original object, it will affect the other object as well, because objects are copied by reference. Everything which is not object in the language, which means string, number, boolean, these are primitive types. All the rest, which is complex, or all the rest are reference types. Everything which denotes to an object as type of is a reference type. So let's talk about JSON structure objects we saw in the previous example. JSON, JavaScript object notation, is something that is used everywhere. It's used in services. It's a better way, in my opinion, to transfer data than XML. It's a better notation for hierarchical data. And JavaScript is, since this is called JavaScript object notation, JavaScript is very well connected to JSON, and you can work with JSON quite easily and well with JavaScript. For example, here we're creating an object, so we're putting it in the curly braces. That's the base of the JSON object. And we have properties, which are defined by name, and then we put column, and we give them values, and we can put multiple properties separated by commas. Properties can be primitive types, they could be object types, or they could be functions. So for example, this object, person, has a property first name, which is assigned to a value, last name assigned to a value, and toString, which is assigned to a method. Here, a function. So once we assign all this to this variable will have this property, and this function as a method. For example, we are here calling person dot toString. This will call this method. It's not the best way to construct objects, but it's the simplest way to do it in line. So again, here it is. The problem with this notation right now is that everything is hard-coded. Yeah, you see? My object is just a hard-coded object, which is defined in here. If I want to create another object like it, or somewhat like it, I have to copy-paste this into another object and hard-code everything. For example, the function toString, I'll have to put in the other object as well, and I'll have to put all these properties manually. So here we're printing out the object. This will invoke the toString function and will print out this. Then we have a function that will rename it. That means that we're actually going to the object properties and changing them, again, by default values like we saw before. I just don't want to get into this, but let's say that this one will rename the properties of the object, and then we'll print it again. Since these are reference types, we're changing the actual values. Okay, so we have the first printout and the second printout after we've checked. Just to note that the function toString is the default name that is called whenever you take an object and you want to stringify it. So if you have an object of any type and you want to be able to cast it to a string, when we call print right line here, we're printing out a string. And what happens by default is that if there is a method called toString defined in your object, it will be called. That's something built into the JavaScript language. So this will be called first and printing out the names, and then we have this function that changes the first name and last name. Right now it's only called with one variable, so two variables, so it will change only the first name, and then write out the result. It's clear. Is it clear to you? Okay. This is an alternative way, by the way, to define this person object. We'll see other ways as well. But if I uncomment this, that's an alternative way to declare the same object. Instead of writing it with JSON notation, I can create a person by calling the new object constructor, and then just assigning properties to names and to functions like this. This will also work the same way. So now if I go here and I refresh, I'll get the same result. So one option is to just do an inline notation of JSON. Another way is to create an empty, just a blank object by calling the abstract object constructor and then assigning arbitrary properties to variables or to values. But we'll see better ways. So again, building objects, you can use JSON, but like I said, it's not very economic. So if I want to build two objects like this that will be representing people, so the first object up there, we have first name, last name, and toString function. Then I want to create another object which will have the same functionality, the same property, because we talked in the beginning about like an account, which will be our class. But if we want to actually reuse the same properties of a bank account or a person in another object, what we'll have to do is we'll have to rewrite everything again. So that's a very bad way to do it. This will work only if you have a very unique implementation that actually builds an object just in this very specific case. You need a variable with this structure, but this is not a reusable object class. Here's an alternative. Again, not the perfect one, but a better one. Here's a function that returns a variable. So we have a function called buildPerson, and it has only one statement of return. And what it returns is an object that is also, again, built inline, hard-coded in a way. The only thing that is dynamic about it is the first name and last name. So it gets them as argument, constructs the object, and returns it. So every time we call this function, we'll get back an object, which will have a first name, last name, and toString function built into it, implemented like this. Print out the first name and then the last name. So this way, we can have two different objects here. Doesn't matter the names of the variables we assign them to. It will build a person object, will assign the names into them, and these will get returned as objects. It's exactly as building an object like this, but it's a bit more economic because there's a function that takes care of the structure for you. So again, I'm getting lost. These are actually the same, exactly the same slide, just different comments. Yeah, like I mentioned, this is almost the right way, but it's not exactly. I also put the word constructor in double quotes because it's not really a constructor. This is just a function that's hard-codedly building an object and returning it. Not good enough. But let's see it, just before we move on. So, here it is. We have an object here. Again, it's hard-coded in structure, and it's built every time you call the function. It just gets a first name and last name and assigns them here into the object that it creates. Again, copied by value, because these are expected to be strings. And here are two variables that call this function and just get this return value, which means they get this object. And every time we call writeLine here, we're calling the toString function, which will take the first name and last name and put them together. So these are two different objects, two different instantiations of this anonymous class, which is returned by this function. But it works. So object properties, like we saw, you can have different properties of the object, attributes sometimes they're called, or properties. There are two ways to actually access properties in the object. One of them is with the dot notation like here, and the other one is with the square brackets like here. They are actually equivalent. If you go and you do a for in loop to go through the properties, you're going to have to use the square brackets because you'll get the name of the property every time, and with the name, which is a string, you'll be able to resolve it only like this. If you have a property, if you know the property, you can access it directly by writing the code object.property name. This also goes for functions because functions are actually just other properties in your object. Very simple demo. We're calling the JS console is an object which is defined in this JavaScript file. It has a property function called writeLine, so we can call jsConsole.writeLine and print out a string, or we can call JSConsole and by square brackets access the writeLine property, which is a function call. That means we have to specify here the function parameters in brackets and call it. This should give the same effect, and we get the printout of the string in both cases. Objects are also, that's again the overlapping of objects and arrays, because arrays are actually objects in the language, and you can go through the properties of the object using the for in loop and get other properties of the object just as they were arrays, but some properties of the array are not supported by what we call, let's say, low key objects. So this is a way that what we see here is a way that you can go through an object and go through its properties. In this case, probably an array. Not sure about if it should be an array or not. But you can see that it could behave like an array. We could iterate through the array with a for in loop with an I variable counter of the loop, and every time we get a property that we can actually access in our object using the square brackets like we did with the other. So what we're constructing here is another object which gets each of the words in the original object sorry, and counts them. We're building here a dictionary of counting each of the words that appears in the original object. Again, I don't want to get too much into tiring details about this notation, but what you need to know here is that you can access properties of the object just like as if they were arrays by an indexer that you can go through with the for in loop, and that you can access those with square brackets like you see here. So maybe the demo will be with more concrete samples. So what we have here is some textual string, and we call the function called getWords. And getWords will go through our text, and text is actually a string. We'll see strings a bit later, and we'll see that we're splitting the string by spaces. This is a regular expression to split the string by spaces, and counting the words each time. And I don't know why this example has to be so complicated. No, I mean, it doesn't serve our purpose. It's just complicating because it's getting into trying to explain to you why it's doing it or what it's doing. So we have get words and we have count words. So count words is actually the one we saw in the slides. It goes through words in the in our object or array and goes through them with a for in loop and checks if a word is already in this word count array object, and adds a counter every time, counts if the word already appeared there. So this is a simple word counter, and this thing actually what it does is builds an array of the different words that we have in the text. So splits them and removes empty words and returns an array of words, and then we're going here and counting them according to their appearance in the text. Again, I don't know how much value this example will give, but you can see that it goes through all the words in the text and counts how many of those appeared and prints them out. Okay, I want to show a little bit more about the right way to build objects in JavaScript. And I have this fiddle. And I think that's maybe more important than the previous examples. If this can be readable, it will be nice. Okay. Here's, according to me, the right way to define an object in JavaScript. If you're not using JSON notation, there's also a way to use JSON notation, and I'll show you a similar example when we're talking about namespaces. But when we want to actually define a class in JavaScript, a type, we can use the function. And instead of actually getting a JSON object and returning it, what we're defining here is a function which is a constructor of an object. So what you can see, everything between the curly braces will represent my object. I can use the keyword this in order to set properties of the current object. The word this actually refers to the current instance of the current code of the current object in the current context that I'm in. So if I'm inside a function, this will refer to this object, and this object in the context of a function is the object that represents the function itself. A little bit cumbersome explanation, but what happens is when I call the person function, it will instantiate an object in the name of this function and will set these properties implicitly in it. So I can send to this function first name, last name, and age, and I can set here properties of my object. And for example, the toString, which will get did I define this full name? Maybe I didn't define the full name, but assume that this has a property called full name. We'll see if it okay, I'll tell you about this in a second. So ignore this full name for a second. So here we have a function called toString. It's a function, it's an anonymous function, but I'm again assigning it to a property of the object, which is represented by this function, the person, and it will return a property called full name and the age here, which is concatenated all of those in a string. Here, as I mentioned, if I create a variable inside a function which is preceded by the keyword var, I'm actually creating a variable which exists only in the context of this function. If I create a property called first name with the word this, I'm actually extending my object, and anybody who's using this person object can access first name property by person.firstname. But if I create a variable inside here, which is a variable which is internal of the function, I cannot access this variable externally. So this is what we would call, let's say, private variable, because it's not accessible outside, and these are public properties because they are defined with this keyword, and they actually extend the object which is returned by this function. Since age here is a private variable and I cannot access it from the outside, what I can do is I can create a getter and setter functions, like here, get age and set age, that are accessible externally, and they manipulate my internal variable. So this is how it should be done, and this is how it's constructed in other languages. So theoretically, after this, ignore this for a second, the full name, because we'll see it now. I'll show it to you. But I can now declare a variable called p, and I can instantiate it like this with a constructor. And what I need to give it is the first name and the last name and an age. And in that case, I've created myself a person with a constructor. This is how objects can be defined as self-contained functions. They can have private and public properties, functions. They can be accessed. So in this case, I can use p dot first name, which is a public property of the person here. However, if I have already an object and I want to extend it, I can always use the prototype accessor, which is a public property of the object, of every object in JavaScript, which allows you to extend any object that you have. So, for example, here I've created a person class, because we don't have the keyword class in JavaScript, we use the word function. But I can use person with a capital P here, prototype, and I can extend the prototype by adding 2 more functions here. These also, on top of that, they use getter and setter keywords here. And what this actually creates is a new property called full name. And every time I assign some value to it, it will call this function here. Let me show you. So once I've extended the person object like this, I can access the full name property like this. Let me create an object here, an instance of the object. Okay. So now I have created an instance of the class, an object, and I can call, for example, an alert, and I can print out the object that I've just created, dot, let's say, full name. That's a public property that I've added artificially into my object here. And when I call full name like this, it will call this getter function and will return this string. So what I'll get is something like this. So what I get is a concatenated string, which is constructed here, and it is part of my object. As you can see, I'm accessing it as part of my object properties. I can call any other properties of my object as well. So, for example, first name. So it will take out the first name property, which is public. But I cannot, for example, access age, which is a private property. So this will be undefined. So this is a bit more complex, but that's the right way to create objects. So if I need to create another person, person 2, I can just call the constructor again using the new keyword. and I've created another object. This is much more intuitive to read. This is much better because I have separation of properties inside my object with this, and I have getters and setters to stuff that I don't want users to access, and I can enhance my object by using prototype afterwards by adding new properties, and I can even have implicit getters and setters like this to create new stuff that will happen implicitly. So for example, here's my first object. Again, note that here the full name setter will take the string, split it by the space, and assign stuff to first and last name. So if I say equals to AB, and then I alert my object, which we'll call the toString, we get the updated values printed out. Yeah. Okay, now I want to show you another way, another thing. Here's another class called Superhero, and this one actually is another class with different properties. It's called Superpower, which gets another variable here, and it has another function called demonstrate superpower that returns a string, icon something. But what I'm doing here is I'm calling the constructor of the previous class, and also I'm extending the prototype of Superhero by person. This means that I'm actually creating inheritance. So what I'm doing is, here for example, I'm creating a new object, and I'm instantiating it with this constructor. This is an inherited class. That means that it has all the properties of the person class and the superhero class. So that's how you can create object inheritance in JavaScript. So here, for example, printing out properties, this will call the toString from the person class, and this will call the demonstrate superpower from the superhero class. So here you go, the properties from the person. This is called person toString, and then when I do the other alert, it will call the demonstrate superpower, which will call this function. Okay, I think this is a bit more valuable than what we saw so far. And one last thing that I want to show is that you can also extend existing objects in the language. For example, I take the date, which is a built-in class in JavaScript, and I can go to, and I can extend the prototype here by adding a new function of my own. So I go to the date prototype, and I add another new property that didn't exist until now, and I assigned it to a function here. And what I'm doing is I'm returning a very custom-built string. So for example, now, when I create a new date, that's a built-in object of the language, I can call this function, which didn't exist before, and it will return this very custom string. So when I call this, I get a very custom-built string. All right with this? It's quite a thing, I know, for 5:40 in the evening. And two last quick demos about what I wanted to show you about objects and closures. Again, we're going back to the curly braces and what they can do. Here's an example. Ignore this function, it just writes lines into the output. Here, I want a function that every time I call it, it will increment my counter. So one way to do it is to create a global counter which doesn't relate to any function, and then call this function, which every time will print out my global counter and then increment my global counter. It will work, and when I see that this writes count globally, you can see that count globally actually increments the counter in every call, and that's great. But it's not great because I have to use a global variable, and God knows who's going to mess with this variable. And the right way to do it is to encapsulate variables inside your functions so that no people will start meddling with them. You need a self-enclosed work to do in your function. So supposedly I could do it like this. I could create a function and declare the variable inside, and then I print a string called count locally, print the counter, and increment it. The problem is that every time I call this function, the variable will be redeclared from 0, and it will not really be incremented. So count locally, you'll see that doesn't really increment the counter. So we don't get the effect that we want. Then we have a better option, slightly better, still doesn't work, count with nested function. So we are declaring the counter here again. And here, what I'm doing is I'm creating an internal function inside my function, and I'm trying to increment the counter here, because this counter comes from the outside, and it shouldn't get affected in here. It shouldn't get reset every time. So count with nested function actually, as you can see, also doesn't work. The right way to do it is with a closure, and it's a little bit tricky. What do we see here? We see here a variable that's assigned to a function that has no name. And this is what we call, again, anonymous, self-contained, auto-executing function, because we're defining it here, and we're immediately calling it here with those parentheses. So this will be called, first of all, this function will be called. Immediately when the moment that the JavaScript interpreter finds it, it will call it. This means that it will build this kind of object, and it will initialize the counter. And from that moment on, it's like we've created an object. And this counter will be internally created, and since this is in the closure of the function, it cannot be accessed by the outside, but it can be accessed by the internal function. But the internal function is called every time we call this function, but since we had it already created once, we have an object at hand, so we have the counter alive, and every time we call the counter with a closure, what we're doing is we're actually returning this call. And what we've done is created implicitly an object which also has an internal function that increments the counter. A little bit complicated. Little bit. But works. Another example, almost similar example here is giving the same effect. Create an object, put the variable inside it, and make an incremental function inside the object. So what you do is increment it every time with the existing object. The effect is the same, but what we have here is a slightly different notation of the same thing. If I just change a little bit, we'll say this is equal to that. So instead of assigning it to a variable, I do it like this. Call it a var. Put your function inside a self-enclosed and make it run, and then call the function. So it's the same notation that will give you the same, should give you the same effect. What's missing? Something's missing. Ah, yeah. Okay, this sample is really hardcore, but I think it's quite important. And it's being recorded, so don't worry. You can watch it over and over again. The last thing I want to show here is about namespaces and how they are handled with JavaScript. Just very quickly to show that you can build objects inside objects, and the same JSON notation that we've seen before. You can create a variable and assign it to an object, and part of the properties of the object in the JSON are actually internal objects as well. And then we have another object inside and another property, which is a function. And in order to access this function here, we have to go through the outer object, the inner object, the inner object, and then call the function. That's how you actually create namespaces in JavaScript. Just nesting JSON objects. This is the same inheritance that I showed you in the previous demo, but you can see that I've created, again, an empty object up here, which has nothing, and I've created a sub-object of it, which is instantiating an object. Here we call it a parent class, and here we call it a child class, which is also another object which we are calling the parent. So we're creating an inheritance here and adding another function to the child. What I want to show here is that you can create namespaces and objects in a hierarchical way, and you can access them through namespace calling like this. So I said it, it's recorded, so you can see it later. I'll also send you these samples. I think this could be valuable because in more advanced JavaScript, you'll see a lot of classes which are defined by functions, like I showed you before with the person. There is inheritance, there is changing of prototypes, and there is this structures of namespaces and closures that I showed you, that you can define things and inner functions that go and run inside other functions. So this is quite a jump to hardcore. That's why I gave you the first slide about where we're going to dive, and it's different than what you've known, but it's valuable.